Hey, 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 it's me, Mr. Pounce. And I'm here with section 2.3, and this is on biconditionals and good definitions. So, kind of two parts. Um, so, our goal for today, your learning target, is to be able to write biconditionals and recognize good definitions when you see them. So, what we're going to do is just dive right in, all right? So, we're going to try and actually make this quick because this is something kind of confusing, I would say, at the start, but. Um, if you kind of understood conditionals and converses, inverses, contrapositives, then this will actually come pretty easily, hopefully for you. But take good notes. So to start, a biconditional is a single true statement that combines a true conditional and its true converse. Now remember, the converse is just making it the reverse, so flipping it around. Um, So biconditional can be written by joining the two parts of each conditional with the phrase if and only if. Oh, I think there's different ways to write that, to abbreviate that, but most commonly I believe it's just if, two F's. All right, so example. So if you have the conditional statement, remember conditional statements are just if-then statements. So if a triangle has three congruent sides, then the triangle is equilateral. The converse would be if a triangle is equilateral, then the triangle has three congruent sides. And if you're thinking about if they're true or not, they are both true. So if both the conditional and the converse are true, then we can make this biconditional statement. And the way we're going to write that is we're not going to use if and then anymore. We're just going to make it a statement and say it doesn't really matter which order you do. I'm just going to pick the first one. I'm going to say a triangle has three congruent sides if and only if it is equilateral. And by making it a biconditional like this, if you see a biconditional, that means that it does work both ways. Meaning, you could say that a triangle is congruent. If a triangle it has three congruent sides, then it's equilateral. And you could flip it around. You could say if a triangle is equilateral, then it has three congruent sides. So that's what a biconditional is doing. It's just combining those two true statements that are opposites like that. So let's look at number two. It says the conditional statement below is true. Write its converse. If the converse is also true, combine them into a biconditional. So the statement is if two angles are right angles, so if they're both 90-degree angles, then they are congruent. The converse, and that's definitely true. We know that's true. The converse then, I'm going to actually type it so I can fit it, would be if two angles are congruent, then they are right angles. So is that always true? I don't think so. We could have two 30-degree angles that are congruent, and they're not right angles, so that's false. So we cannot make a biconditional out of that. Sad face. Let's look at number three. It says, write the two statements that form the biconditional. So now we have a biconditional. We want to write the conditional and the converse that would make this. So it says the product of two numbers is a perfect square. If and only if, that makes it a biconditional. Whoops. The two numbers are identical. So we could say this as a conditional saying, if the product of two numbers is a perfect square, then the two numbers are identical. Okay, that would be a conditional statement. If the product of two numbers is a perfect square, then they are identical. Now the converse of that just be flipping around. If two numbers are identical, then their product is a perfect square. And I know we're losing it there. There we go. I'll make it a little bit smaller so it fits here. Okay, and that's true as well. If you have two of the same numbers, when you multiply them together, it'll make a perfect square because you could take the square root of that and get that number. So finally, number 4, last one dealing with biconditionals. It says, test each statement below to see if it is reversible. If so, write it as a true biconditional. If not, write not reversible. So it says a linear pair consists of two angles with measures that sum to 180 degrees. A linear pair consists of two angles with measures that sum to 180 degrees. So we're going to rewrite it as a conditional. We're going to say if two angles form a linear pair, then their measures sum to 180 degrees. That's true. If two angles sum to 180 degrees, then they form a linear pair. Now, whether they're both true or not, I want you to go back and look at what the definition of a linear pair is. Now, that oftentimes is true, but remember, a linear pair needs to form a line. So it has just a line going out of it. So this angle A and this would be angle B. Those form a linear pair because they make a line. I can come up with one counterexample, so this is true, to make this one here false. And that would be taking this angle and this angle. They're not touching, they're not making a line, but yet they're both 90 degrees, so they would add up to 180 degrees. Okay, so that's just my example. If they're not touching, if they're not forming that adjacent side, then they won't necessarily be a linear pair. Okay, just be careful with that one, because that's a very tricky one to think about. But that's the last one we're going to do with biconditionals. Just remember, biconditionals are no longer conditional statements with the if-then, but they're combining a conditional and a converse that are both true, just using if and only if in the middle. All right, real quickly on good definitions. What are good definitions? So a good definition is reversible, meaning it's a biconditional. And it can be written as a true biconditional. And it avoids using vague, imprecise, or difficult words. So if it's very general, very vague statements, it can't be a good definition. So let's just look at a few examples and see how we do it. It says, is the following a good definition for a square? Definition: a square is a rectangle with four congruent sides. It's very short and to the point. It's pretty specific, like it's a rectangle, meaning it has to have two sets of parallel sides and four right angles. And here it says four congruent sides. So far, it works. Let's see if it's reversible. So we could say, if a rectangle is a square, then it has four congruent sides. If a rectangle has four congruent sides, then it is a square. So it is reversible. So yeah, we'll say this is a good definition. And yes, we just talked about how it could be written as a good. This can be written: a square is a rectangle if and only if it has four congruent sides. Or a rectangle is a square, sorry. Alright. Then how about this one? I have two of them for you. I want you to do them both. Think about if they're good definitions or not. State whether each statement is a good definition, and explain your answer. Number 1. A triangle is a three-sided figure whose angle measures sum to 180 degrees. Number 2, in basketball, the top scorer in a game is the player who scores the most points in the game. So let's go back to number 1. A triangle is a three-sided figure whose angles measure some whose angle measures some to 180. So if we could make it reverse, well, we could say a triangle. So if if a triangle if the shape is a triangle, then it is three-sided with angle measures to 180. If a shape has three sides and angle measures some to 180, then it is a triangle. So this one, yes, I would say is a good definition. It's pretty precise. It's kind of, I would say it's a little wordy, but it's a pretty good definition. And the last one, in basketball, the top scorer in a game is the player who scores the most points. If we could reverse it, we could say in basketball, the player who scores the most points is the top scorer in the game. Yeah, it's pretty, it makes sense. It's pretty simple, but that's a good definition. All right, so that covers good definitions. Just remember what a good definition is. So now I'd just like to close it with this closing question. It says, now that we've looked at good definitions, write a good definition of a biconditional. Might be a tough one, but explain what makes your definition a good definition. And that's what I'm going to leave you with. Um, think about that as you think about that goal that we started with, uh, with biconditionals and good definitions. Be able to write them and recognize good definitions. All right, that's all for section 2-3 today. Have a great rest of your day.